thing we're going to look at is using the distance formula to calculate the length. And we're going to talk real quickly about what the distance formula is. Some of you will still want to use Pythagorean theorem like you did in the previous unit when you have things in the coordinate plane. So here's what the distance formula is. You take your x and y points. You have some point, it could be called A, with an x sub 1, y sub 1 coordinate, sub 1 meaning it's your first point. Point B with an x sub 2, y sub 2 coordinate, sub 2 meaning it's your second point. Just like slope, but it doesn't have to be in the order of slope, you're going to subtract your x's. That's the first thing you do, is subtract the x coordinates. You're also going to subtract your y coordinates. Now when you look at this formula, it looks crazy because it has all this other stuff that we're going to do to it. But if you follow the order of operations, this is the first thing you do. Subtract your x's, subtract your y's. After you know their difference, which it might be negative, that's okay, you're going to square those numbers. That's the second thing you do, is square those numbers and then add the two numbers together. And that'll give you your value that goes under the square root symbol, because the last thing we do to get the distance is take the square root. I'm going to show you why we do that in just a second. But that's the distance formula. It's in the back of your book. You can Google it. You get the same thing. Yes? It honestly doesn't matter. When we do slope formula, it does matter. If I start with the second or first point, I have to be consistent and do the same thing for the x's. I can switch the points order. It doesn't matter. Same thing here. Honestly, here it wouldn't matter if I did x sub 1 minus x sub 2 and y sub 2 minus y sub 1. It was still going to work out. You're going to get the same thing. So we're going to subtract the x's, subtract the y's. Gentlemen, you want your table to stay after lunch? And you're going to square them, add them, and take the square root. Now I'm going to show you why this formula works real quick. Let me pause. I'm just going to create a new sheet. So in our coordinate plane, you don't need to write any of this down. We have a point. We'll call this one x sub 1, y sub 1. And we have another point up here, and I want to know their distance. Because it's not a horizontal or vertical line, I can't just count tick marks. Okay? I'm actually going to have to calculate it.
Why couldn't you make a triangle, kind of how we did?
That's what we did before, and that's what I'm going to do to explain the distance formula. We want to find this. I could count tick marks horizontally, right?
Yeah.
That's the value of A. This is the value of B, and this is really C up here, X. And before you guys just said, oh, A squared plus B squared equals C squared. Just use Pythagorean theorem to find the length. And that's what we did, and most of you were fine with that. But here's the thing. The length of A goes from here to here. From x sub 2 to x sub 1. So it is the difference of really x sub 1 minus x sub 2, but x sub 2 minus x sub 1, it's really the absolute value of that distance. Hey, if it's from 1 here, if that's a 1 and this is a 5, then it's 4 units long. So A is actually, that length, is x sub 2 minus x sub 1. It's like saying, hey, this is 5, 3, and this is 1, 4. Well then, if you want to know how long it is from 1 to 5, it's 4 units. Or I could do 5 minus 1 and get the same thing. Now in terms of y, this height is y sub 2, y sub 1. This height is y sub 2. One of them is supposed to be y sub 2. This height is y sub 2. This height is y sub 1. If this is 0 and this is 10, then it's 10 units high. Or I could do 10 minus 0. Y sub 2 minus y sub 1 would give me this height right here. So that means that B is y sub 2 minus y sub 1. Well, I don't want C. C is x in this case. How am I going to solve for x? How am I going to get x by itself when it's squared?
Divide square root.
Take the square root of both sides. Gee, what does this thing right here look like?
Oh, that looks a little different.
That's the formula. Well, that's the formula that you have on the first page, right? The distance formula that comes directly from Pythagorean's theorem. Yes. I can pick the second point to be x sub 2, but that's x. It's an xy coordinate. X sub 1, y sub 1, x sub 2, y sub 2.
And
Yep.
see the example. So confusing.
Yeah, it could be x sub 1, y sub 1, and this could be, the one down here could be x sub 2, y sub 2.
It like doesn't matter.
Doesn't matter. All right. So you can pick. You can use Pythagorean's theorem as you solve these in quadrants. You can also just use the distance formula. Right now, I want you to try this problem using the distance formula. You could plot it, but it's not going to be fun when one of the numbers is negative 25 and the other is 17. So what do you do first? What do we do first in the distance formula? Do I do the square root first? Do I square them first?
Parentheses, PEMDAS.
So I'm going to subtract first. You're going to
What?
take your points and you're going to subtract first. Then you're going to square it. Add them and take the square root. Go ahead and do that.
35.
Some of you did this correctly, but some of you might have made a mistake. So if you did negative 25 minus negative 10, what is that actually? Plus 10. And then you have 17 minus 2. By the way, you could do that part right now in your calculator. Don't forget to put the squared on them, though, if you're going to do it all at once in the calculator. So this is 15 or negative 15 squared. This is 15 squared. Doesn't matter whether it's positive or negative. When you square it, a negative times a negative is positive. So 225 and 225 adds up to 450. So this is the square root of 450. Some of you got a decimal approximation for it. That's okay. It didn't say leave it in simplest radical form, so, but it also didn't say what to round to. So if I break this down, 25 goes into it. It's exactly 225 times 2, which is 15 square roots of 2. It's exactly 15 square roots of 2. That would be approximately a different decimal value. I will tell you, if you're using decimal values, it's okay if it says leave your answer to the 10th or 100th, but if you're going to use those numbers to help you calculate angles, how many decimals do you need to round out to?
4.
4, so that you don't get a rounding error when you plug it back in to calculate other values. So here's our first example. We have point A at 2, 1, point B at 4, 9, and point C at 7, 6. Now it's important that we know this is a right triangle. They're going to tell you, it does say all of them are right triangles. If it's not a right triangle, can I use SOHCAHTOA?
No.
Or Pythagorean's theorem? No. But I could still use the distance formula to find the side lengths. So I'm going to start by finding, and you can find it underneath. I'm going to find it to the side so you can still see everything on the screen. By finding AB, the distance from A to B. We're going to do that by subtracting my x's, subtracting my y's.
It's a lot of work.
Well, if you're feeling lazy, I mean, you should be able to do that pretty easily. It's 3 and 8, right?
Right.
So 9 and 64. But if you're feeling a little lazy, you have something that can help you. You can simply do I think it's more work to punch it in the calculator, but you can. Just make sure if there's the double negative, you plug that in correctly, or it might not work out. So this is 68. Is it 64 plus 4? 68. So AB is the square root of 64, which square root of 68, sorry.
Wait, how'd you get that?
Plug this into the calculator.
I just did the math. Science is math.
Two options. I'm going to make a note down here that it is the square root of 68. When I go to find the angles, that's what I'm going to use. I might even put it here. But technically, I can't give that as my final answer for AB. I either need to break it down in simplest radical form or give the decimal answer. And since they didn't say I had to leave it in simplest radical form, technically that's probably what I should do. I'm going to raise it to the power of 1/2, which is the same as taking the square root. I get 8.2462. If you're going to use the decimals to find angles, Shady, your table needs to stay after class. The talking is continuing. If I'm going to use the decimals, I better make sure to round out 4 places, yes. You can put it in simplest radical form, yes. That's actually more accurate. BC. I'm going to do 7 minus 4 and square that. I'm going to do 6 minus 9 and square that. Add the two together, take the square root. BC is the square root of 18 in simplest radical form. That would be 3 square roots of 2. Or, rounding out, 4.2426. Now I actually have enough information already to find my angles. I'm going to do the same thing to find side AC, just in case I messed up on one of these. I don't want to make an error on that too. So for AC, 7 minus 2 squared, 6 minus 1 squared. That's 25 and 25, which is 50. So AC is the square root of 50, which is going to be 5 square roots of 2. How do I know that my sides are correct when I look at this right triangle? That is 5 square roots of 2. Yes. What's true for right triangles about their side lengths? The squares of them, yes. So if I squared this, this would be 50. Square root of 50 squared is 50. That didn't work. And square root of 18 squared is 8, or square root of 18 squared is 18. And square root of 68 squared is 68. These two add up to 68. So it does follow Pythagorean theorem. I know I calculated my sides correctly. To find my angles, it's a little tricky. You get to pick. Did I give you any angles other than the right angle? No. Nope. So I can't use triangle sum. I need to use sine, cosine, or tangent inverse. And we get to pick. Since we know all 3 sides, we get to pick. When I go to find angle A, maybe I look at the opposite side and the hypotenuse. What trig function would I use if I was using opposite and hypotenuse?
The inverse of.
Please don't sin. It's not sin, it's sine. But you are correct about the trig function. It is sine of A would be square root of 18 over square root of 68. But I want the angle, not the ratio. If it was a quiz question that said, tell me the ratio, great, I'm done. But I want the angle, so I'm going to do what? Sine inverse of the square root of 18. You have to be careful. If your calculator is one that has that square root of parentheses, you'll have to close them before doing the division. Divided by the square root of 68. And then I have to close the parentheses on the sine inverse. And it tells me 30.9, so 31 degrees. Now, a lot of people just want to find angle B by subtracting from 90. or subtracting the 90 and the 31 from 180. That's really how we should check our answer. We should do another trig ratio to find angle B so that we can verify we did both of them correctly. I'm going to do opposite and adjacent. So which trig function should I use? Tangent. So tangent of B is square root of 50 over, what was that other one? 18? Square root of 18. So in my calculator, I'm going to do tangent inverse of the square root of 50 divided by the square root of 18. Close the parentheses on the inverse, and it gives me 59 degrees. And those add up to, what do those two add up to? 90. With the 90 gives me 180, so I know I did my angles correct also. Any questions on this problem? We're going to go through the next example, but before we do, I'd like you to take a minute to plot x, y, and z and see if you can find the correct lengths for xy, yz, and xz. You can put it in simplest radical form or round out 4 decimals, you can choose.
No. Just count.
Nope, we didn't need the distance formula to find xy because it's a vertical distance, so we could have just counted. Some of you did the distance formula, you still got square root of 64, which is 8. So you save yourself a little time there if you recognize that that's a vertical distance, we can just count
Dang it,
the
why did you
marks.
tell us that?
For xz, be careful with that minus and negative. (16 and 16 is 32, so that's the square root of 32, which in simplest radical form is 4 square roots of 2. And the same is also true for yz. You should have gotten the same thing for both of those. Is there anyone who did not get those numbers? Okay. Well, I can tell you right now that I already know the angles in this. I'm going to do the work to show you how I could get them using trig, using sine, cosine, or tangent inverse.
I got
But I already know. Raise your hand if you already know what the angles in this triangle are. Good, some of you already know. Who can tell me why you know the angles in this triangle? Susan. It is a 45, 45, 90. It's an isosceles right triangle. The two legs are the same, and it's a right triangle, so it is 45 and 45. So here's the thing, if this were an assessment item, I would have, and I wanted to do that without doing the inverses, I would need to write that out in a sentence explaining, hey, I know this because it's isosceles right triangle, they have to be the same angle, they're right opposite angles will have to be the same, so they're 45 degrees each. If I didn't know that, I could use tangent inverse. Here's the opposite, here's the adjacent. I could do tangent of, is that z? No, y. Tangent of y is square root of 32 over square root of 32. And by the way, I get the same thing if I did the tangent of the other angle, x. And when I do tangent inverse of that, oh, disappeared. Okay, anyhow, when we do tangent inverse of that, we're going to get 45 degrees. Because that's really the tangent inverse of 1, which is one of the ratios we know from our special right triangles. So either way, we still have evidence, either an explanation of it being an isosceles right triangle, or using inverse tangent, inverse sine, or inverse cosine. In this packet, you have a couple other problems to work on. You don't need to do the triads. I want you to do the ones on the back page that say 8.3 coordinate triangles. And we will be going over those later this hour. So your goal is to finish those 4 problems.
Which ones?
When we come back from lunch, you can start them now.
You said you don't have to do the triangles.
The ones that say try these, you don't. On the next page, there are some problems. We're gonna work on those. By the way, do you have to do distance formula if it's horizontal and vertical lines? You can count. So do that if it makes it easier for you. Okay? Find all side lengths, find all angles. And then we'll go over the learning targets that are going to be assessed on your quiz on Friday.